Today, we're jumping into AI development in Java using Spring AI and LangChain4j with Quarkus. If you're a Java developer looking to get into AI apps, this video is for you. We'll build two starter apps, one using Spring Boot with Spring AI and another using Quarkus with LangChain4j. We will go ahead and include the Neo4j dependencies for now, even though we won't use them in this video. This will give you a place to continue development, adding retrieval augmented generation, agents, or beyond. Let's get into it. To begin with, we will start with Spring AI, and in order to do that, we will go to their Spring Initializer. And the Spring Initializer is a great place to build a template for a project. We'll stick with just the basics defaults there on the first few properties, but I'm going to go ahead and switch this to a Neo4j group. And we can call this anything we like, but I'll just start with Spring AI Starter App. And then we need to include a few dependencies. First off is we want to build a REST API in order to interact. And so we're going to create the Spring Web dependency to our application. Now we need to create some dependencies for Neo4j. There's a couple that we want to include here. In order to run queries against Neo4j and map those back to Java objects, we can use the Spring Data Neo4j module. And then we also want to use Neo4j in the future as a vector store to store embeddings and query those embeddings with vector similarity search. So we're going to add the Spring AI Neo4j vector database dependency. Last but not least, we need to choose a large language model. For today's use case, we're going to stick with OpenAI. However, Spring AI supports a lot of large language models, so you can pick and choose and swap this dependency out with whatever you prefer. With this all set up now, we can generate the project, and this will download it. And then once that's done, I can open it up in my preferred IDE. The first thing we need to do before we really start digging in on some code is to configure a couple of things. The first one being our OpenAI API key. Now, if you're using a local model, you probably don't need an API key, but for most of your public models, you'll need some sort of key in order to access them. I'm just going to put in an environment variable that I have set on my computer to populate that. Now, I also need to include some configurations to connect to Neo4j. I'm going to use a public database that's available for you to use as well if you'd like. Now, there's a couple of things if you're using Neo4j as a vector store, a couple of extra configurations you can add to this. Those are available in the repository if you want to take a look at those, but this is all we need for right now. Now let's get started with our application. The Spring Initializer will create the main method, but we're going to create a controller class to interact via REST. So in order to do that, we'll create a new Java class. We'll call this AI controller. And we're going to set this up as a REST controller. And then we're going to set a default endpoint to start us off of /chat. Now, first thing we need to do is we need to inject a chat client. This will allow us to connect and chat with the LLM, in our case, OpenAI. We also need to create the constructor for this to inject it into our class so that we can use it. And then we want to build this into our constructor as well. So we're going to call this builder, and then we can do the builder.build, and that will take care of that. Now we can set up an endpoint for us to connect. We're going to do a public string response. We're just going to call this chat. And we want to pass in a request parameter. And we can call it anything we like. Just take their default selection there. And we'll run a return, call the chat client, and use the .prompt, passing in that message. And then we'll want to call the LLM. What comes back is a large response object. We really only care in this example about the content key, which is the string answer that gets returned. So we will just return that. Now, if I've set everything up correctly, I should be able to run this with Spring Boot :run with Maven. This is looking good so far. Open up a new tab. And I'm going to use a curl alternative called HTTP. You can use curl if you'd like, /chat. And then we want to pass in message equals what are the benefits of Neo4j in GenAI. And it'll take it a couple of minutes, but here's the response that we get back. It offers several benefits that can enhance capabilities of generative AI, GenAI applications. Here are some key advantages. And it lists 10 and then summarizes. Okay, this looks good. Now, Quarkus's online code generator tool is very similar. I'm going to change just a couple of details here. Neo4j as the group, and then we can call this Quarkus LangChain4j starter app. And we'll need a couple of dependencies here as well. First one being we need some sort of REST dependency. This is going to help us create that REST API. We also need a way for us to serialize some JSON potentially. There's a lot of implementations and ways you can do this. I'm just going to pick JSONB for today. And then we need our Neo4j dependency here, using Neo4j as a vector database, just as we did with Spring AI. And then last but not least, we need our model. This is where OpenAI comes in. And again, lots of models supported. We're just going to pick OpenAI for today. Now you can see 4 dependencies, looks very similar to the way we did it in Spring AI, and then we can generate the application here. We're just going to download. Same thing that we did with Spring AI, we need a few configuration details. The first one being, of course, that API key. We're going to have OpenAI key, and I set that as an environment variable. One other thing that I have found that is nice is to change the timeout to 60 seconds. I think the default might be 10, which is rather short. Extending this even a little bit helps avoid some of those timeout errors. And then we need the connection details here. So same thing as we saw before. We need this Neo4j. I'm going to use that public demo database that you can also use if you'd like. Database name of Goodreads here. Because we have the dependency of Neo4j vector store, there is a configuration that's required out of the box, even though we're not using the vector store today, and that is the number of dimensions in your embeddings. This will change based on the embedding model that you choose. Because we're using OpenAI and their default model, it has 1,536 dimensions in the embedding. Just be aware of that. You may need to customize that depending on your model. Then there would be some other things for the vector store as well that you would need, things like the index name and so on if you didn't want to use the defaults. Now, Quarkus also does create a general REST endpoint for you in this greeting resource. However, we're going to go ahead and create our own, similar to what we did in the Spring AI application. First, we need a way to interact with the large language model. So we're going to create an AI service. I'm going to call this AI service. We're going to register this as an AI service. And then we need to create a method that's going to interact with the LLM itself. So we can set up a few defaults, the first being a system message. This could be anything, rules, details, a starter for how you want the LLM to behave. We're just going to start off with a generic, you are a helpful assistant. And then create a user message. This is what the user is going to send in, that it wants the LLM to respond or do something with. And in our case, we're going to send the input as we did last time with Spring AI. Then we're going to set up our method name. We will call this string chat, and we'll want to pass in our input from wherever we call it. The next thing that we need is the actual endpoint. Now in Spring AI, this was called the controller class, but in Quarkus, they typically use the naming resource. So we're going to call this the AI resource, and we are going to scope it for the application. And then we're going to set up a default path, just as we did with Spring AI. We're going to call this /chat. The first thing that we need to do is inject our service so that it has access to that. So we can inject that with AI service. And then we also need to include it in the constructor, just as we did before. All that looks good. And then we can set up our endpoint. It's going to be a get method, and we're going to have it produce a media type of text. And then we can set up our method here. So string, we're just going to call this chat. We're going to send it a query param, and it's going to be call it message, just as we did on the Spring app. Call this string message. And then we can call the AI service.chat and send that message as input. If we've defined everything correctly, I should be able to run it with Maven, but instead of the Spring Boot, we can type in Quarkus:dev. Okay, and all that looks good. So now we can run against our endpoint here. So similar as we did before, /chat, and type in message. The answer that comes back should be very similar or pretty much the same to what we saw in our previous application. Here, Neo4j's powerful graph database offers significant advantages for generative AI, GenAI applications. Here are some benefits. And it's going to list, well, actually 11 of those this round. Hopefully, these applications provide starting points to integrate vector stores for retrieval augmented generation and beyond. Next time, we will add another layer to integrate source data to improve LLM responses with retrieval augmented generation. Stay tuned and happy coding.